Imagine, in the depths of the solar system, a gigantic planet slowly rotates, resembling a work of art with its mysterious rings. While stars light years away silently observe it, it is shaken by storms, filled with oceans of gas, and rules over dozens of moons. This mesmerizing planet is named Saturn. Saturn is famous not only for its rings but also for its mysteries. What is happening in its atmosphere? Why is there a massive hexagonal storm at its poles? How did its rings form and why are they so bright? And most importantly, is there really a possibility of life on Saturn? In this documentary, we will examine every detail from Saturn's formation to its current mysterious structure, from the storms on its surface to possible signs of life on its moons. Guided by science, but explained with the sincerity of human language, in this journey you will discover Saturn not just as a gas giant, but as a cosmic story. Because Saturn is not just a planet, it is a poetic narrative of the universe. Saturn formed about 4.5 billion years ago from the collapse of enormous clouds of gas and dust orbiting the Sun. This process created not only the planet itself, but also its rings, moons, and the entire surrounding system. Saturn, categorized as a gas giant, does not have a solid surface. Its internal structure is layered, each containing different physical conditions formed over time. Its outermost layer is a dense atmosphere containing frozen ammonia, methane, and water vapor. This atmosphere is divided into bands of yellow, golden, and brown tones. These bands are the result of giant wind currents, just like on Jupiter. However, compared to Jupiter, Saturn's atmosphere is much thinner and more delicate. Beneath the atmosphere is a hotter and denser layer of hydrogen and helium gases. The deeper you go, the pressure increases, causing the gaseous hydrogen to liquefy. Scientists believe this liquid hydrogen transforms into a state known as metallic hydrogen, even deeper inside. Unlike ordinary hydrogen, this substance can conduct electricity, and it is likely the source of Saturn's magnetic field. And what about the core? It is estimated that Saturn has a dense core of rock and ice at its center, with a mass several times that of Earth. However, this core has not been fully observed, so it remains a mystery. The core's temperature may reach up to 11,700 degrees. Interestingly, Saturn constantly loses energy from its core to its outer layers. In a way, this planet still works like an internal heat pump. This is one of the main reasons why Saturn is hotter than expected. Have you ever looked through a telescope and seen Saturn's unique rings? If you have, words may not be enough to describe how breathtaking that view is. And if you haven't, don't worry, because now I'll take you into the depths of those rings. Saturn's rings are among the most striking structures in the solar system. First observed in 1610 by Galileo Galilei, he couldn't quite understand what they were. He thought they were the planet's ears, but in 1655, Christian Huygens correctly identified the structure as a ring surrounding the planet. Since then, Saturn's rings have captivated scientists and sky watchers alike. So what are these rings actually? The answer is quite surprising. They are a mix of ice, dust, and rock particles. Their size ranges from microscopic ice crystals to massive blocks several meters wide. And the most astonishing part, these rings are extremely thin. Despite spanning thousands of kilometers in width, their thickness is only a few hundred meters. This makes them one of the thinnest and most delicate structures in the universe. The rings are divided into 6 main groups: A, B, C, D, E, and F rings. The brightest and thickest are the A and B rings. Between these two lies the Cassini division, a large gap created by the gravitational effect of Saturn's moon Mimas. Although scientists cannot determine the exact age of the rings, most research suggests they are relatively young. So, Saturn's rings may have formed long after the planet itself. Some theories propose they resulted from the breakup of an icy moon that once orbited too close to Saturn. NASA's Cassini spacecraft collected immense data on Saturn's rings. In fact, Cassini revealed that the rings are thinning over time and slowly raining onto the planet. So these elegant structures may not be with us forever. As impressive as Saturn's rings are, its orbiting moons are equally remarkable. Saturn has 145 known natural moons, surpassing Jupiter as the planet with the most moons in the solar system. Each of these moons is like a separate world, some massive, some only a few kilometers in size. But a few have captured the attention of scientists and telescopes for years. Titan and Enceladus. Titan is Saturn's largest moon and also the second largest moon in the solar system. It's nearly as big as Mercury. But what makes Titan special isn't just its size. It's the only moon known to have a thick atmosphere and to hold surface liquid. Titan's atmosphere is rich in nitrogen and structurally similar to Earth's early atmosphere. Covered by a thick haze, its surface couldn't be observed for many years, until NASA's Cassini-Huygens mission sent a lander to its surface. In 2005, the Huygens probe landed on Titan and discovered riverbeds, lakes, and even sea-like formations. But these liquids aren't water. They are hydrocarbons like methane and ethane. In other words, Titan has rain, but the rain is liquid methane. Scientists believe a vast ocean of liquid water may exist beneath Titan's surface. If true, this ocean could be larger in volume than Earth's oceans, and that makes Titan one of the most promising candidates for potential life. Although not as big as Titan, Enceladus might be Saturn's most fascinating moon. Its surface is almost completely covered in ice, looking like a bright white sphere. But the most exciting discovery was that plumes of water vapor and ice particles erupt into space through cracks in its surface. When the Cassini spacecraft analyzed material from these cracks at Enceladus' south pole, it detected salty water, organic molecules, and hydrogen. This indicated a subsurface ocean of liquid water beneath the surface. Moreover, these plumes allow scientists to collect samples from the ocean without having to dig. This makes Enceladus a perfect target for future life search missions. Saturn's other moons are not to be underestimated either. For example, Mimas. With its enormous impact crater, it resembles the Death Star from Star Wars. Iapetus. One side of its surface is completely dark, while the other is bright. This is due to differences in surface composition. Rhea, Tethys, and Dione. These medium-sized moons continue to be studied for their surface features, crater structures, and historical geology. Saturn, with its massive gaseous structure and incredible moon system, is a true scientific treasure. The potential for life on Titan and Enceladus makes the Saturn system one of humanity's top space exploration targets for the coming decades. Saturn is not only a visual wonder, but also a magnetic giant. It has the second strongest magnetic field in the solar system, after Jupiter. But Saturn's magnetic field operates differently from all other planets. Saturn's magnetic field is almost perfectly aligned with the planet's rotation axis. This is unique among solar system planets. Normally, magnetic fields are tilted. Even Earth's is off by about 11 degrees. But Saturn's deviation is nearly zero. This symmetry has baffled scientists because it cannot be explained by classical dynamo theory. That is, it's hard to understand how rotating conductive materials in Saturn's core can create such a perfect field. This remains one of Saturn's unsolved mysteries. Saturn's powerful magnetic field is also visible through its polar auroras. These light displays, like Earth's northern lights, are created when charged particles from the Sun interact with the magnetic field. But on Saturn, they are much larger and shine brightly in ultraviolet wavelengths. The Hubble Space Telescope and the Cassini spacecraft have captured these auroras many times. At Saturn's poles, these lights form a crown around the planet. This spectacle reveals both the beauty and cosmic power of Saturn. Like Jupiter, Saturn is a gas giant and has no solid surface. But the structures beneath the surface are quite layered. Upper atmosphere filled with ammonia crystals and ice particles. Storms and jet streams form here. Middle layer contains liquid hydrogen. Due to increasing pressure, gaseous hydrogen becomes liquid. Inner layer, the layer of metallic hydrogen plays a role in generating the magnetic field due to its electrical conductivity. Core. Scientists believe Saturn's center holds a solid core of rock and ice. Compared to Jupiter, this core is smaller, estimated at 15 to 20 Earth masses. Cassini's data suggests this core may have fuzzy transitions and overlapping layers. This means Saturn's internal structure is more complex than previously thought. Saturn reflects much more light back into space than it receives from the Sun. This suggests an internal heat generation mechanism. The most accepted theory is that helium droplets mix with hydrogen and sink toward the planet's center. This process, called differentiated settling, produces heat. So even though Saturn looks cold and silent from the outside, it works like an internal energy factory. Saturn's hidden aspects are incredibly impressive. Its magnetic field, polar auroras, and mysterious internal energy flow make it a grand puzzle waiting to be solved. Saturn is one of the most distant planets visible to the naked eye. Because of this, nearly all ancient civilizations recognize this slow-moving light in the sky. In Mesopotamia, Saturn was called Ninurta. The Romans named it after the god of agriculture, Saturnus. The true nature of Saturn's rings began to be understood with the invention of the telescope in 1609. In 1610, Galileo Galilei saw ear-like extensions on Saturn, but due to his limited telescope, he didn't realize they were rings. At the time, people thought they were two large satellites. In 1655, Dutch astronomer Christian Huygens, using more advanced telescopes, confirmed they were rings. He also discovered Saturn's largest moon, Titan. Then Giovanni Cassini, with even more detailed observations, defined the gaps between the rings, now known as the Cassini division. The 20th century brought a revolution in studying Saturn. NASA's Voyager 1 and Voyager 2 spacecraft were the first missions to closely study Saturn. These missions revealed that the rings were more complex than expected, discovered shepherd moons shaping the rings, confirmed Titan had a thick atmosphere, measured the planet's strong magnetic field. These missions gave us an entirely new perspective on Saturn. Saturn's golden age of exploration began with the Cassini mission, a joint project by NASA, ESA, and the Italian Space Agency. It launched in 1997 and reached Saturn's orbit in 2004. Cassini observed massive storms and polar vortices in Saturn's atmosphere, discovered methane lakes, riverbeds, and clouds on Titan, revealed Enceladus's subsurface ocean and water vapor plumes, analyzed the ring's structure and age, measured Saturn's magnetosphere and ionosphere. Thanks to this mission, the possibility of Saturn and its moons hosting life began to be taken seriously. Enceladus, in particular, became a new target for astrobiology. When Cassini ran out of fuel in 2017, scientists deliberately sent it into Saturn's atmosphere to prevent contaminating the moons with Earth microbes. Saturn has nearly 150 natural moons, and some hold enormous potential for extraterrestrial life. The standouts include Titan. With its thick atmosphere, liquid methane lakes, and surface filled with organic molecules, Titan provides the chemical prerequisites for life. NASA's upcoming Dragonfly drone mission plans to land on Titan and explore its surface. Enceladus. Its subsurface ocean makes it the top candidate. Cassini observed water vapor plumes from this ocean and found elements like carbon, hydrogen, and nitrogen, all essential for life. The exploration of Saturn is far from over. In the coming years, the following missions are planned. Dragonfly, NASA, set to launch in 2027, will land on Titan and analyze both its atmosphere and liquid lakes. LUVOIR and HABEX. Next-generation telescopes will study Saturn's atmospheric molecular details from afar. Scientists are also trying to determine the age of Saturn's rings. Are they as old as the planet, or did they form just a few hundred million years ago? Saturn frequently appears in science fiction. Titan is often portrayed as a second Earth in novels and films. Interstellar, The Expanse, and Arthur C. Clarke's works push Saturn to the limits of imagination. Saturn shines like a jewel in the sky, a massive puzzle box full of scientific secrets. Its rings, moons, atmosphere, and mysteries keep humanity's curiosity alive. No matter how far we advance, Saturn reminds us that the universe is still full of the unknown. And now we've reached the end of our journey through Saturn. As we glide between the rings of this gas giant, we feel once again how vast, mysterious, and truly awe-inspiring the universe is. We've seen that a planet is not just cold stones and gas, but a silent storyteller of the cosmos. Maybe Saturn is not just a distant object shining in the sky, but a source of inspiration for dreaming big in our small world. If this journey left you with even a spark of curiosity, a hint of wonder, then together we've come to know the universe a little better. Thank you for joining me on this adventure. Until we meet again on a new planet with a new story, don't forget to look up at the sky. Goodbye.